Welcome and thank you for joining today's webinar on SAP Integrated Business Planning and SAP Advanced Planning and Operations. During our presentation, we will go over the differences between IBP and APO, discuss if IBP was created to replace APO, talk about the capabilities of IBP, and to answer common questions about IBP and APO. Next slide. Today's speaker is Shailendra Kumar, the Senior SAP IBP Functional Consultant here at Krypt. Shailendra has been an integral part of successful implementations of SAP IBP projects worldwide and has worked extensively in process designs and configurations. On the next slide, I'll go over some quick housekeeping tips. If questions come up during the webinar, please type them into the panel as shown in the example. We'll be addressing them at the end of the presentation. If we run out of time and don't get to your question, we'll be sure to follow up with you afterwards. On the next slide, I'd like to quickly introduce Krypt for those of you who are less familiar with us. Krypt was established in 2008 and is the leading SAP consulting partner. Although we operate globally, we consider ourselves a boutique consulting firm that lives by our founding principles of innovation, collaboration, and drive. These principles have allowed us to complete over 800,000 SAP consulting hours in various industries. Our services focus around implementations, upgrades, and for various SAP solutions, including trade, transportation, warehouse, planning, IBP, and HANA. We also offer proprietary solutions, integration services, and work closely with SAP for ramp-ups and testing. On the next slide, I'd like to share some of our thought leadership. We strive to be thought leaders in the supply chain ecosystem, and we've accomplished this by authoring books in addition to writing blogs and white papers, which are available on our website. Moving on to the next slide. This is an overview of our proprietary offerings, which complements the SAP suite. I wanted to briefly highlight Krypt Connect, located in the middle of the solution list. This particular solution can be integrated with non-SAP ERP systems, which many people find valuable. Moving on to the next slide. Over the years, we've had the opportunity to work with a variety of companies within the SAP supply chain space, and some of them are highlighted here. And with that, I'll pass it over to Shailendra.
Thanks, Rachel. Thanks a lot. So welcome everyone for today's webinar on IBP APO versus SAP IBP and SAP APO. So ever since this SAP APO has been there, it has been widely used for advanced planning. It's called as advanced planning optimization. It's been used for demand planning, supply network planning. You have GATP, global availability promise. Then you have PPTS and SAP APO. Everyone is familiar with SAP APO. And then suddenly in 2012, SAP bought this new product, Integrated Business Planning. And it was formerly called as SNOP, Sales and Operations Planning. Then they renamed it to Integrated Business Planning 4.0, then 4.1, and then they came up with the different versions. And latest we have 1902. And in the month of May, we'll be having IBP 1905, I'm sorry. So here is it like, is there a competition between the SAP APO and the SAP IBP? It's like these two products are there. APO is there in the market. IBP is the new offering. So is it going to replace it or is it going to act as a complement? So everyone who is thinking like SAP APO and SAP IBP, these two products are competing with each other, for them, the answer lies no. They're not two competitors. The SAP APO is not competing with SAP IBP. Look, every client, every customer is different. They have different challenges. They have different problems. These two are different products. They are meant to solve these challenges. Some of the challenges can well be solved by SAP APO. Some of the challenges can well be solved by SAP IBP. It is meant to solve the challenges. Then what do we have for an agenda for you? So let's see. We'll do a product comparison of an SAP APO and SAP IBP. We'll see where SAP APO is moving, where SAP IBP is moving. We'll see how it can be compared to so that it can fit into a box where the correct box, which can be used by the clients to solve their business challenges. scenario involving APO and IBP. So there are certain instances that the clients, the customer already have this SAP APO. Now with this new product, SAP IBP, will this act as a complement to it? How they can use SAP IBP? Why should they use SAP IBP on top of an APO? Some of these we'll see, and we'll figure it out, like how it could benefit a particular industry or business. Then we have a wonderful demo lined up in order to showcase the same thing, like APO, IBP, how you can use it and how it can solve a business challenge. How other components can help. Like there are IBP components such as supply, sales and operations planning, supply chain control tower, response and supply planning. So there are other important components to it. So how they can add a value to your current IT landscape. We'll talk about the advantages of an IBP. We'll see like how it is going to prove a game changer for any industry and how it can be a advantage for any industry, for any business. We'll also see the high level architecture, how it looks like, so that we all have a good overview of good outlook of how the architecture would look like if we have an IBP on top of an APO, or an APO and ECC, and then an IBP comes into a picture, or an S4HANA and an IBP. So how this complete landscape would look like, so that it can solve some of the mysteries that goes around. And then we'll be followed up by the question and answers. So let's start with the Venn diagram of an APO and IBP. So the left half of the left circle, you will find that it's an APO box, and in the right, it is the IBP box. So what's common in between an IBP and an APO? That's in the intersection part of a Venn diagram. That's the demand and supply. So APO has a demand, IBP has a demand. APO has a supply, IBP also has a supply with a response and supply planning for order series and time series. How it is different? There are certain things that is different. So like, let's take an example of demand planning in an APO and an IBP. Let's compare it. So to start with, a demand sensing, you can use it in the IBP, but you cannot use it in APO. But if you have an APO and still you want to use demand sensing, you can have that. So we'll have this kind of scenario in order to see the live demo and figure it out, like how you can overcome that. Now, from an APO, there were PPGS, GATP. So this PPGS and GATP has now moved into an S4. So if anyone has moved from an ECC to an S4, they would probably figure it out, like PPDS and GATP is now a part of S4. And then in an IBP, if you find like there are certain extra features, like for example, a supply chain control tower, which gives you a complete visibility of your supply chain, and then which will help you to control your supply chain. There are like disaggregation and aggregation that you can do it like very simply. It's very simple out there. The what if scenarios, these are some of the very crucial things that help business to take key decisions very less time. So if your planning time reduces, you can take decisions, you can take key decisions at the time which is required, because if if it is delayed, then decision doesn't matter then that much. So it has to be very quick decision. It has to be taken at the correct time. So how this helps, we'll see. Some of extra things, like for example, ABC, XYZ classification. Now we have an IBP, or response and supply, which is like time series and order series. So in a time series, you have like CPITS, and in an order series, which is a SDI, it's a different integration which comes in with the response and supply. So supply, pretty much everything is covered. Demand, a lot of things uncovered, and a lot of algorithms, a lot of machine learning languages that the SAP, they have already started utilizing it in the algorithms. And so there are a lot more what you can do from an IBP demand rather than an APO demand planning. Then this is an Excel-based planning. So Excel add-in, it comes with an Excel add-in. You have an Excel-based planning where you can create your planning views. You have different planning views. You can share, you can edit, um, you can share it with your planners. You can share it with in groups. You can take decisions on that. You can save it as a favorite, and you can design your template as per, like for example, a global and a regional planner will have a different planning views. They will have a different templates. So you can design it. You can have it like us. You can also restrict to a particular planner. So these are some of the flexible things that comes in. These are very flexible in IBP. Let's go forward. So this is how an APO to IBP in S4 looks like. So if you're aware of an APO, here it looks like in the middle. If you see, there was a demand planning, allocation planning, and GATP, supply network planning, and PPTS, as I said in the earlier slide. If you have moved from an ECC to an S4, the PPTS and GATP in the form of an AATP, advanced available to promise, is there in the S4 right now. And in the IBP side, if you see, you have certain extra components, like for example, inventory optimization. That adds a very important, that plays a very key role in sales and operations planning. So let's take an example of a sales and operations planning where you want to take some recommended safety stock, or you want to see like how your stocks are and at the different locations, product level, and you want to take that as an input for your supply planning. Then you can very well have this inventory integrated with your sales and operations planning, and then it would be called as a sales and inventory operations planning, SIOP. Then you have a supply chain control tower to gives you an advantage of like creating customized alerts and have perfect visibility of your supply chain. You can control it. There are a lot more than this. You can play around with these custom alerts in order to solve these problems. Let's take an example. You have a custom alert at a particular location product with respect to your statistical forecast quantity and a consensus demand plan, and then you want to take a decision based on these two comparison and come out with the adjusted consensus demand plan. You can just play around with the dashboard and come out with the solution. You don't have to go inside a planning view to get into the solution. It can very well minimize your work, I would say. So it plays a very smart tool if it is configured, and it plays a very important role in your planning. So as said earlier, IBP demand, it also comes with a demand sensing. So demand sensing, as we all know, it's now becoming one of the key factors for many of the industries in order to figure out, like in a short-term planning, how the demand would change with the recent change in the demand pattern and how it would take. So we'll see one of the demo on how demand sensing would play a key role. And then obviously the sales and operations planning, which is there in IBP. So sales and operations planning is obviously a very important. So everyone wants to move towards a collaborative planning rather than a silo planning. So sales and operation planning is one thing that every industry would like to have it in place. So these are some of the things from where with the APO it is moving to an S4 and the IBP coming into picture. So let's start with one question that generally when we go for an implementation or with a customer interaction, initially they come up with these kind of questions like, I have an SAP APO, I have an advanced planning optimization tool. Already I'm doing a planning, I'm already carrying out a planning, but do I need IBP? Do I need integrated business planning? So look, the answer lies within you. So it depends upon your planning, at what level you are planning, at what maturity curve you are in the planning side. And it entirely depends upon the requirement you have. So if your requirement is being solved by an advanced planning optimization, then why should you move to an IBP? Why should you move to an integrated business planning? Then it makes no sense just to buy a particular algorithm. You buy a full product doesn't make any sense. So it has to be a requirement that fits into this box. It shouldn't be like you buy a box and then fit in all the requirements. No, no, no. So that's a big no. It always has to be your requirements and how it can be solved. So if you have an APO, if it is solving your problems, if you do not foresee any challenges in the future, then yes, well, go ahead with the APO itself and do not buy IBP. But moving forward, there will be like we'll see one of the instance why you should move to an S4 HANA and why you should have an IBP. We'll see one of the instance in the later part of the slide where we'll discuss about like if you are using an APO and why you should consider moving it to an IBP, because IBP is a new tool, we all know, but it's going to play a very key role in future. Then also, we also see some of the questions like one of the question like, can IBP replace APO? So the question again, so it again lies with the business, like, can IBP replace an APO? So if you're using a demand planning in an APO and you are moving from an ECC to an S4, so you would like to have everything on one particular database, S4. IBP is at a HANA database. And if you're moving from an ECC to S4, you can very well move it from an IPO to an IBP, and you can utilize the IBP demand planning functionality fully, because IBP demand planning is quite matured. You can use the sales and operations planning. So if you're only using an demand planning and then you are sending out the results to your supply network planning to carry out your supply planning and then sending out the constraint demand plan back to your ECC, and if you're considering like you should have a more collaborative planning rather than a silo planning, so yes, the answer is yes, IBP should replace an APO where you come up with the sales and operations planning. So let's take a scenario over here. If you are using a demand planning on an APO and then you want to utilize a sales and operations planning, then you are not replacing an APO with an IBP. You are having an IBP on top of an APO with the sales and operations planning component of an IBP, so that once you carry out a demand planning in an APO and then send out your stat forecast quantity to your IBP or your consensus demand plan to an IBP, and then carry out your sales and operations planning where you carry out your demand review, your sales supply review, and then followed by pre-management review and the executor planning, what we call it in the sales and operations planning, a 4-week plan of a month, and you send out the constraint demand back to your ECC for your operations planning. So this could be one picture. So it's not necessarily that IBP should replace APO, but yes, if your challenges are there, if your requirements are such, then it will replace it. So it all depends upon the requirement and the challenges of the different customer and how a system, how a software, or how a IBP or an APO can solve this. Then yeah, what is IBP? What is integrated business planning? A lot of misconception around that IBP is similar to your sales and operations planning, but no. So then what is IBP? So integrated business planning is the business planning process for the post-recession era, extending the principles of sales and operations planning. So it's actually not a sales and operations planning, but it is extending the principles of sales and operations planning throughout the supply chain, product and customer portfolios. If you look at the last slide, to deliver one seamless management process, that's where you call it as a collaborative. That's where you call it all the business will have one single goal. They do not have multiple goals. They have single goals. So in order to achieve a single goal, you need to have a collaborative approach. So that's where the IBP comes into picture. So let's see scenario for adoption of IBP. How an IBP wherein it can play a very good role. So this image is a typical supply chain where you have a customer, you have a plants, you have a DC, warehouses. Your product is flowing from supplier to customer, and customer, your information is flowing from customer to supplier, your money is flowing from customer to supplier. So This is a very typical global supply chain where it's very cumbersome. It looks very confusing here. So this is just a simple part of a global supply chain. I would say a global supply chain would look more complex than this. And if you take one of the point, like for example, a forecast, this will play a very key role in this, because if you do not capture your forecast, if you do not carry out your forecast, if you do not capture your uh, data, the master data accurately, and if you do not carry out your forecast, then it will be a huge problem for you to plan in a supply chain like this, where it will have a bullwhip effect across your supply chain. So you need to have your forecast. Now, how do you monitor a forecast? That's also a very important thing. So IBP does play a very important role in monitoring this forecast and applying an algorithm. So all the products need not necessarily will have the same pattern, need not necessarily will have the same forecast. So it all depends upon the product family or a product group or the historical demand pattern that the product is exhibiting with the customer, with the location. So that where it comes, IBP comes very handy when you have certain these kind of situation, and you can very well play around. You can see, you can manage, you can take a control of it. A lead time is one of the important aspects. So a lead time, like a production lead time, transportation lead time. If you want to see a scenario where you increase a lead time and how it is going to affect your inventories, if you reduce a lead time, how it is going to affect your inventories, and with this affected inventories, how it is going to affect your supply chain, how it is going to affect your capacities. So these are some of the things that you can just play on a fly, with increasing lead time, reducing lead time, adding versions, scenarios, and take decisions into the capacity. So as said, a lead time and then influence of a lead time into a capacity, available capacity, capacity utilization, some of these. Then aggregation, disaggregation. IBP provides a very flexible way of doing an aggregation and disaggregation. So it's not that complex as it is an APO. So in an IBP, you will have you can aggregate, you can disaggregate, you can also run algorithms at an aggregated level, you can take decisions at a disaggregated at a SKU level. So it's very flexible out here and very simplified. Forecast error. So this is one of the very key component, I would say, key parameter rather, I would say. Why key parameter? So the forecast, we have done the forecast, we have done a demand planner has done the forecast. Now if he or she doesn't monitor the forecast, then it would be difficult for a business, because if something goes wrong, like for example, if the forecast is always underbiased, or if it is under forecasted, I would say, like underbiased, then it will have an impact on your inventories, definitely, and in turn it will have your impact on your supply and the sales side as well. So the forecast error, measuring this forecast error is very important. And how do you measure it, and how do you involve this forecast error into your decision making and into your scenario planning? That's also very equally important for any business. Visibility. The more the visibility you have in your supply chain, the more control you will have in your supply chain. Like for example, at a particular DC in a particular customer region, you want to control it by assigning some of the alerts on the movement of an inventory, so that if it passes if it overshoots any limit in any thresholds, then it will pop out an alert. So this is so flexible in terms of a visibility. It empowers you. So you will have a complete control across your supply chain. Too much inventory is a big problem. If you have enough inventory, too much of an inventory, then you are actually having your working capital locked, which you could have otherwise used in some other purpose, like for example, or research and development or sales side or marketing side. But your working capital is already locked in the form of too much of an inventory, and inventory carries a shelf life planning as well. So how inventory IBP for inventory optimization helps in tackling these kind of situation. It comes very handy when you use an inventory optimization, and along with this, if you use it as sales and operations planning, then it becomes very handy. White inventory wrong place is equally a worse problem. If you have a right inventory but it's in the wrong place, then it's similar to having a too much inventory, or even more worse than that. SIOP, as I have discussed in the earlier slide, like how you can involve an inventory into a sales and operations planning and make it a more collaborative approach in order to solve your inventory woes or your supply planning. So service level, what type of, how much of a service level you should have at a customer facing DC, how much of an internal service level is good enough in order to achieve the customer facing service levels. Let's take an example here that a particular DC which is facing customer, you maintain a 90% of a service level. But if you do not consider the internal service level from warehouse to DC into that picture, what will happen? You will have to stock a lot of safety stock in your customer facing DC node. But if you consider your internal service level from warehouse to DC also simultaneously, that too in your inventory optimization, what will happen? It will calculate the optimal service level you should have at an internal service level. So from a warehouse to DC, it might be like you can have it 72%, and at a DC you should have a 90%. So everyone knows, like in a DC it will carry a huge amount of holding costs, and in a warehouse it will be almost half of it. So it is always advisable to have enough safety stock at your warehouse rather than a huge amount of safety stock in a DC. So what is an optimal inventory that you should have at a DC, and what is an optimal inventory you should have at a warehouse? These are some of the things that inventory does come up with these answers. So this is helpful in coming up with the service level and deciding on all those things. Collaboration, as I've already spoken a lot about a collaboration, how it plays an important role. Everyone wants to move from a silo planning to a collaborative approach, and so that a decision making or overcoming these challenges becomes more easier. So let's look into a business case that I have for today's demo, wherein we'll consider that a client have an APO, Advanced Planning Optimization, already, and they are very well happy with the demand planning at their premise. So it's a plant or a warehouse where they are carrying out their demand planning in an APO, and they're sending out the finished goods to the DC East, DC West, and DC South. Now here is a situation where a demand planner is carrying out demand planning in an APO at an aggregated level. So this planning is at an aggregated level, and he finds that the forecast error or the forecast accuracy is quite high. So accuracy is quite high, error is quite low, and he's pretty happy that yes, he or she is pretty happy that yes, the demand planning, whatever I'm carrying out, always it has a very good accuracy level. But whenever the DC sales or the DC warehouse people, whenever they come across, they find that at every start of the week, their inventory is either too low or the inventory is either too high. There can be a situation like this. Whereas in this particular, in the first pattern, if you see, if the daily replenishment from a warehouse to DC happens based on the aggregated demand planning level, it will have a pretty straight line. But the DC sales or a DC withdrawal is like you have less than what you are replenishing. So actually in the start of the week, you're having an excess of inventory. You are holding an excess of inventory. And at the end of the week, you are under inventory. You are having a shortage of an inventory. So this is a problem. This is a problem, because even if you are carrying out a demand planning at an aggregated level, you're looking things at an aggregated level, and it looks like your accuracy is too high. But also If you see at a DC level, if you see at a disaggregated at a DC SKU level, you will find that there's a pattern going across, and at an aggregated level, you are not able to identify this pattern. And what happens at the end of the week, you are having a shortage of an inventory. At the start of the week, you are having an excess of an inventory. This is just an example of a one SKU, but just imagine for a global supply chain how big this problem could be. Let's take another pattern where you have been replenishing based on your aggregated base planning, and you are facing a shortage of an inventory at the starting of the week, and you're having an excess of inventory at the end of the week. So what happens in this case? You are running out of sales at the start of the week, and you are accumulating a lot of inventory at the end of the week. You are actually holding it. You are actually holding an inventory in your DC. So in these two cases, if you find your working capital is locked. So how you can minimize these issues, how you can solve this problem? If you look at the third case, it's pretty simple that you are having a very flat demand from that particular DC or in that customer region, and the way you are replenishing is perfect. It's going very, very well. But in the first two cases, it's a problem. It's a root. So what is the root cause of the problem? You need to find the root cause. So what would be a root cause? It's a demand pattern. Every product has a particular demand pattern, how it sells from a particular DC to the customer region. So every product has a demand pattern. Now, how do you measure this demand pattern? How can you take this demand pattern into your demand planning so that you can come up with these kind of demand planning? And it would be nice, like, if you replenish your inventory in the form of a demand pattern that is showing after taking some of the demand signals. So what could be a demand signal that you can very well take in a form, take it as an input for your demand planning so that you can come up with this kind of demand pattern? So like, for example, a promotions, DC withdrawal, how frequently or what pattern your DC withdrawal is following, a POS, point of sale data, consensus demand. So these are some of the way that you can have your demand signals, but these are some of the factors. I'm sure that there are many more that you can take in, but you can take it as an input for your demand planning, for your demand sensing. But these are few that you can very well take into, and you can come up with a demand pattern. So let's go into the system and see how you can do it. So this is an IBP or cloud, it looks like. If you see, it has got some of the apps that is for a particular specific task, and all the apps are meant for a particular task and to make things very simplified, very easy. Okay, so now let's go into the Excel sheet. This is how you can do it. You can prepare your planning view. You can prepare your template based on your requirements. So it's quite flexible. You can play around with these icons here, and you can come up with your template, your planning view. So once I have taken in all the actual quantity from my APO, so in this case, I have an APO, and on top of that, I'll place an IBP so that I can come up with a demand pattern, and then I can monitor my demand planning, and then I can flow my data from my consensus demand to my supply planning. So this is how the scenario would look like. The supply chain that I'm talking about right now is this is a supply chain that, sorry. So yeah, this is a supply chain that I'll be looking around, and I'll be looking around this particular DC, and these are the customers. So I'm going to look in just one part of this particular supply chain design to go with this today's demo. So let's go back into this Excel sheet, and here if you see, so what I've done is I have taken the actual quantity or the historical quantity from my APO system, and I have cleansed it out, removed the outliers, removed the promotional value, removed the null values, through some of the algorithms and come up with the adjusted values, and then I will use my adjusted values for demand sensing. So I have an algorithm of a demand sensing here, which is which I can just which I can configure it. So what I'm going to take is at a day level, I'll take some historical periods and I'll forecast it for next 42 days. And then I'll come up with the forecasting steps where I'll configure it based on the parameters, and based on the parameters, it will come up with the demand pattern that I'm looking forward to, based on the demand pattern, based on the some of the demand signals that the product exhibits. So from here, I can go and run my stat forecasting, and I can just run it from here, and I'll select different options here. Like for example, I'll select the day because the demand sensing only works at a day level, and I'll select the demand sensing. So here, if you see, there are two options, a sensing and an update. So what's the difference between a sensing and a sensing update? So generally, first time you should run a demand sensing. Why? It will recognize the pattern. So for that purpose, you will run a demand sensing. It will recognize the pattern. It will come up with the output. Now, going forward, like for example, a new sales history has been captured, and that would not change the pattern though, because that will be like compared to your 365 days, that will be like a week or a two, which is not going to impact your full demand pattern. So in that case, you will only run a demand sensing update. In that update, it will take the recognized pattern and it will come up with the adjusted quantities, or the sensed demand quantities, I would say, a sensed demand quantities in the future with the new sensed demand quantities, so that it takes the recent history into picture and come up with the new sensed demand quantity. So here you can just run a demand sensing, and then you can have a filter over here. So in my case, I'll just run this filter. So I've already executed this particular algorithm, so I will not run this time because it will take some time to run, and then I will come up with the demand sensing. So let's go back and look into the dashboard, how it looks like. So now let's look into the picture first and the APO side. Okay, so in an APO, a demand planner has executed this demand planning statistical algorithm and come up with the consensus demand weekly. So a consensus demand weekly would look like is looking like this kind of pattern. It has a consensus demand weekly, and if you see, if I just break this down into a daily pattern, it will have a picture like this. So if you see, even if I go into a daily pattern of a consensus demand daily, it will have like it shows me that your daily replenishment from your warehouse to your DC, it should be pretty much an average kind of. But then let's go. So considering that this input I have taken from an APO to an IBP, I've executed my demand sensing with the input of demand signals such as DC withdrawal, POS data, and then what I figured it out is the next step. Now let's look into this thing. If you see over here, your consensus demand was a sensed demand weekly. This is what is a weekly pattern. It looks pretty similar right here. It doesn't look very different. But if you look at the daily pattern, here you figure out a problem. And what is the problem? Even though your accuracy was high when you were carrying out a demand planning at an aggregated level, you figured it out that at a detailed level, it's a problem. And here is the root cause of the problem. The withdrawal seems to have some kind of pattern. So if you still follow this blue line, you're actually at this sometime of the week, you are having an excess quantity of inventory, and at some time of a week, you are having a shortage of inventory. So this is how your demand pattern would look like on a sense demand, right? So let's go back into the Excel sheet and see. So if I just look into this particular, so at the end of the demand sensing algorithm, I will have a picture kind of this, wherein you will have a actual quantity, that is the historical quantity, you have a sense demand quantity. So this is how your sense demand quantity would look like at a weekly level, and you will have a consensus demand plan quantity at a this is at a weekly level. Now, but if you look this, the pattern is pretty similar, right? If you look at this blue line and the green line, this is pretty much overlapped, because the consensus demand, it looks like the consensus demand and the sense demand at the weekly, it's the same. But if you look at the daily bucket, here is the pattern that goes around. So this is what will actually make a key difference. Now, suppose a planner, suppose a regional planner for this particular product wants to make some changes into a sense demand. I'm coming into a different picture now, where you have a sense demand quantity already. Now a planner wants to add some of the inputs to it. Let's say that he or she is not pretty happy with the sense demand quantity that has come up and the consensus demand, the difference, and he wants to have, like, he or she wants to have like a 600 quantity. Now, how you can make it a more collaborative approach, how you can add a value to it. So let's say that he or she has added a 600, and to here, what I'll do is I'll save this data. Now, once I save this data, this will overwrite my sense demand quantity final. Okay, now what if I can add a planning note to it, so that if I share this particular sheet with the other planners, they would be able to see why I have added the 600 quantity, and what is the reason, and who has added, and what time it was added. So let's make this. So what I've done is I've configured this planning note. This planning note is pretty similar to what you have a comment section in your Excel sheet. So now, once I have added this, I can add a planning note. I can just mention like Shavendra 600 QTY. Please check. Now what happens that this becomes a planning note now. Now if I share this, if I add it as a favorite and share it with the different users, I can share it, and the person with whom I've shared this particular template or a planning view, they would be able to see this particular note and would be able to see like at what time it was checked, what comment it has, and what are the different things. So this is like a different approach to it. So it adds a quite a value to it. Now, once you have the sense demand quantity final, you can very well use this as a consensus demand plan at your weekly level for your supply planning. But at a daily level, you can have this kind of replenishment, which can actually help you in your inventory stock at your DC, customer facing DCs. So if you look over here, you have you can see very well the difference between like how a demand sensing can add a value to your demand planning, and with this your accuracy level would be high, and you will not have a problem that we have seen, like excess of inventory or shortage of inventory. There could be some plus minus, but yes, up to a certain extent, that would be like a huge advantage for any industry, for any business. You can very well have some of the custom alerts. So if you look, I have like few custom alerts where a consensus demand plan and the sense demand plan quantity, if there is a difference. So let's take a custom alert here that if a consensus demand plan is more than 130% of sense demand plan quantity, then it should give me an alert for that particular customer region, product family. You can have it at different levels: customer region, product group, customer region, product location, location type, customer region, product. So you can have it at any level and at any part of your supply chain. So this is how you can have an alert, and with this alert you can actually solve this problem also. Like for example, if there is an alert here, you can go into this particular Excel sheet. You can have an Excel sheet attached to this particular alert, it will redirect to that particular Excel sheet. You can change the quantity there, and then you're back here, and you will see that the alert has gone. So this is how it can solve some of the problems by just looking into the dashboards and working out only with the dashboards, and you can take care of the alerts, or you can take care of the problems that is lying there in the supply chain. So there are many more dashboards that you can create, but here are some of the which was linked to our business case today. So with the interest of the time, let's move forward. Okay, now the inventory dilemma. This is one of the important things that comes across a lot of supply chain, that what is the problem of an inventory dilemma? What are the problems? Like, for example, the demand variability. If your stat forecast is not, the algorithm that you're using for your stat forecasting is not correct, or if you are having an unbiased, if you are having a positive bias, or if you are having a negative bias of kind of a situation, then there is a problem. These will be actually affecting the inventories that are stacked into your locations at different nodes of your supply chain. Your forecast error is equally important, like your how you are calculating, whether it's an MAD or you are taking like MAPE, and how you are considering that as an input into your inventory planning. So if your forecast error is too high, it means it is directly proportional to your safety stock, that your safety stock will be too high. So if every business would like to have the forecast error at the minimum, so that you can have a safety stock minimum. So these are some of the inputs that drives your inventory planning. Supply uncertainty, like for example, your lead times. So if your lead times are too variable, then it will definitely affect your cycle stock, and in turn it will affect your safety stock. So these are some of the things that you should consider when you are taking a decision on inventory planning. So this will directly impact, like how about here, like in a customer facing DC, or in a warehouse, or in a plant. So when you talk about a plant or a warehouse, it's a internal service level that comes into a picture, or from a warehouse to DC, internal service level. And if it is going to impact your DC, then it's a service level, it's a customer service level that is going to be impacted. So in whole, if you see, it is going to impact like your full supply chain. Then what would be the consequences, like high or uncontrolled inventory levels? Yes, obviously, and then inadequate inventory availability, customer service level. So if you look into a bigger picture, there's like this is a very huge challenge in front of any industry, in front of any company or business, and everyone wants to solve this inventory dilemma. So how does integrated business planning, IBP for inventory, comes into a picture and helps it? So let's look into this particular graph in the left hand side, and you will find that in the IBP for inventory optimization, it takes all these locations simultaneously. All the locations simultaneously at one number of iterations in background, and then come out with the recommended safety stock, not only for the finished good, but also for the components at a component level, also at different locations. Unlike any other product, which first calculates at a plant, then a warehouse, then at a DC. So if you calculate at a plant and then come at the warehouse, you're actually adding a buffer in the warehouse. You're not coming up with the optimal safety stock, you are adding a buffer because of the variability in your internal service level, or a variability in your lead times. Then when you come to DC, you are adding more extra buffer. The same reason. So IBP for inventory, it actually eliminates all these things, and it considers all the locations simultaneously and comes up with the plan, comes up with the recommended safety stock. All the stocking nodes are taken into consideration simultaneously. And obviously, as I have earlier said, that inventory, though inventory is not a part of a sales and operation planning, but if you include this in your sales and operation planning, it will be a very good game changer for any of the industry or business. Supply chain control tower, if you have alerts, if you can have a control all across your supply chain, if you have a good visibility all across your supply chain, you can control your supply chain. So a supply chain control tower plays a very handy role in this case. Like for example, we have seen in case of a sense demand quantity and a consensus demand quantity, even though we at the aggregated level there was no problem, but at the detailed level we see that there is a problem. Now, how did we come across that? If we set up an alert and wherein the consensus demand plan is more than sense demand quantity of a 130%, then it should pop out an alert for me, and from that alert I want to take a necessary action in that product customer location level. So you have this alert populated out, and then you from there you will be redirected to the Excel sheet, and you can just play around with the number, share it across your team with the planning note, and then there is a consensus in between all the planners, and then you come up with the correct plan. So this is one of the way to approach a problem or solve a problem. Advantages of an IBP. So we have already seen some of this, like end-to-end comprehensive view of a supply chain, current and historical supply chain performance. Yep. So if you have a comprehensive view of a supply chain, your supply chain performance would be very effective. Then alerts quickly identify. So we have seen some of the case, one of the case, like for example, where you have an alert of a consensus versus sensitive and quantity, and how you can solve it a problem, which I just explained. And then the collaboration. Yes, a collaboration approach, like for example, just a very simple case that I've shown, like adding a planning note and then sharing across, and then so this is one of the way. But yes, in a sales and operations planning, you can very well include your inventory and your supply chain control tower and your demand planning, so that you can, and it becomes a full comprehensive collaboration approach where you have a demand planning, your sales and operations planning. In a sales and operations planning, you have a demand review, supply review, pre-management, and then executive review, and then you carry out your operations plan. So this is one way. Now, real-time scenarios and simulations, so you can carry out a what-if analysis, like for example, changing the lead times, and want to see like how your recommended safety stock behaves at different locations at the customer-facing DC, and how the component safety stock would behave, component stocks would behave at the different locations. So demand supply chain, financial model at an aggregated detail level. Yeah, these are some of the advantages of an IBP. And then, and in a nutshell, so what gives you an IBP? What IBP as a product provides you? So if you see, it's a simplified experience. Like for example, we have seen one of the demo in where it looks very simple. It looks very simple, though the configuration and the work behind it is yes, definitely a lot of work behind it. But for a planner, for an end user, it becomes a very simplified way to control your supply chain, to look into your supply chain, to solve the problems of your supply chain. So that is what is very important, how a planner looks like, how an end user looks like. So it becomes a very simplified experience and gives you a unified empowerment. Then a high-level architecture. So in the left-hand side, if you see, it's any legacy system. So you will have a data service agent installed at the customer environment, and then in the right-hand side, you have the cloud or the HANA, where you have the IBP along with your CPI. So if you procure an IBP, you will have a CPI along with that, and you will have an agent service installed at the customer environment. So a data will move like from it. You can connect this to any legacy system. So any other database or a flight file or an AP or an ERP, you can connect this IBP and bring in the data from the legacy system or an ECC S4 system into an IBP, carry out planning, and then send out the end results to your operation plan or your ECC or your S4 to carry out the operations planning, like for example, the production planning or a warehouse management or a sales and delivery or your procurement planning. So some of these which is definitely going to play a very key role in the future, and where IBP comes into play, where IBP plays a key role involving some of the technologies, like for example, machine learning. We have already started using a machine learning in some of these statistical algorithms, Analytics, yes, it has got a wonderful analytics. If you look into the views, if you look into the dashboard, the amazing analytics you can create it in the IBP. Big data. So let's take an example of a big data here. And why do you need an HANA? Why do you need a database so powerful? And if you need a database so powerful, how it is going to help, like IBP, how it is going to help you as a planner to solve the business challenges. So consider in your supply chain the products, location, resources, and components. You can just think about of an average number. It will look like a very huge, and then you just multiply this with your 2 to 4 years of planning horizon. What you will have, another huge number, a too huge number, and then you have a sales, finance, supply plans, and scenarios. So how much data you have right now? So it is billions of data points. It's billions and billions of data points. So in order to compute these billions of data points, come up with the solution, you require a very powerful database, and that's the HANA. It has an in-memory computation, so that makes it different from any of the database that is available in the market. So HANA brings you edge in these kind of situation, and IBP, where it is based over an HANA database. Now you can think of the time required for planning. Now you can think about time required for solving those plans and come up with the decisions, come up with the key decisions and take those key decisions. So if you take a key decision at the right time, it is a meaningful decision. It helps your business. Some of the experiences, like for example, we have seen customer getting like 1 to 2% of a top line revenue growth, inventory turnover getting better with the 5 to 15%, and these will not only help your individual components of an IBP, but if you see at an overview or overall, it will help your revenue, it will help your inventory turns, it will help your demand planning, it will help your supply planning, it will help your operation planning, it will help your financial targets achieving and annual operating plans, coming up with the annual operating plan. So these are some of the things that you can very well figure it out, and there are many more. There are many more benefits. Yeah, so that's it from our side for the today's webinar. So over to you, Rachel. So if you have any questions, please ask me.
Thank you, Shailendra. It looks like we do have a couple of minutes here to answer some questions that have come in. First question is, if I have an ECC and APO, then how would a system landscape look with an IBP?
Okay, so if you have an ECC and an APO, now there are two things you should look after it now. If you're migrating from an ECC to an S4, then you can very well have an IBP, and you can utilize some of the components of an IBP from the day one, and you can have this IBP on top of an S4. But if you are not ready to move to an S4 and you are very well okay with an ECC and an APO, and then how an IBP would play, how an IBP will come into a picture of your IT landscape, then from an APO, you can have your data flow to your IBP for your, let's take a sales and operations planning, inventory planning, control tower for dashboards and all those, and analytics and all these things. And then once you freeze out the plan, once you come up with the constraint demand plan, at the end of the sales and operations planning, you can throw the data well back to your ECC, and this, so it will be like ECC, you are sending out the data to an APO to carry out your demand planning, and then from a demand planning, you move out data to an IBP for your sales and operations planning, and then move your data back to your ECC for your operational level planning. So this is one kind of scenario. To come up with the other scenarios, I would like to have a detailed look into your IT landscape, and then we can come up with a plan like how an IBP can help you, or do you need an IBP? Any of these questions can be answered there. Yeah, Rachel, please.
The second question is, how many demand signals or what type of demand signals can we use?
So it entirely depends upon the customer. So I remember some of the recent conversation with one of the famous dairy manufacturing company where they wanted to use a non-linear demand signal into their demand planning. So yes, you can use any of the demand signal. So the answer to it is you can use as many demand signals you want. So that would actually help in recognizing a demand pattern a lot better. And a demand signal could be like your point of sale data, it could be your daily DC withdrawal, it can be anything. So it has to be at a daily bucket. And yes, this will actually help in recognizing if it's at a daily bucket level, it's well and good. It will help in recognizing the pattern, like how your demand is flowing on a daily basis, and then it can come up with the pattern. Yes, Vijay.
Okay, thank you, Shailendra. Unfortunately, that's all the time we have for today. If we didn't get to your question, we'll be sure to follow up with you after the webinar. We'll also be sending out the slides to everyone in the next couple of days, so keep an eye out for those. Lastly, be sure to visit us this May at Sapphire in Orlando. We'll be in booth 1343. Thank you, everyone, for joining, and we'll see you next time.
Thank you, everyone.